In this section, we are going to look at, what is the title? Seasonal Indexes Multiplicative Model. So in Seasonal Indexes Multiplicative Model, you'll usually start out with something that looks like this. And conceptually, seasonal index acts a lot like a dummy variable. Some people will do regression with dummy variables. Others will do it with seasonal indicators. You'll get almost the same exact response. In this section, they want you to work with seasonal indicators. So what a seasonal indicator does is it takes into account the idea that if you collect data over time, especially data that has some form of seasonality to it, whether it be the type of product that you're dealing with, that it might have some pattern within the data, right? So this pattern might have to do with being like the first or second or third or fourth quarter, where even though there's a pattern to it, there might be a long-term trend and other data that is within it. And so what ends up happening is we make a regression model. A regression model is a model that fits through the points, right? And so with our regression model, we're going to make a prediction at each one of these points as it goes to the data. And what the seasonal indicator does is, okay, put it through the model. And then once you get your prediction, I want you to multiply it by my indicator to force my data to either go up or down, depending on how it's acting within the seasonality. And that's all we're trying to do. And so what you'll always get is you'll always get a model. It's kind of y equals some slope that you're dealing with, right? So we'll call it beta 1, or beta naught, some intercept, plus beta 1, which is our slope. But they'll always do it times t, because the trend, the underlying trend, is found by doing 1, 2, 3, 4, 5 inside the model. And so when we look at this question, it says, the quarterly number of permits granted for building houses in a large city is seasonal. There tend to be more permits granted for construction during the spring and summer months than during the winter months. The following data shows the quarterly seasonal index for building permits. So quarter 1 would be winter, quarter 2 would be spring, quarter 3 would be summer, and quarter 4 would be fall. And so when we get our answer, if we multiply point by 0.6, it's going to shrink our answer. When we get this answer, we're going to multiply 1.5, which is going to make our answer bigger, because these are the months when it's bigger, the other two are months when it's smaller. So these are our seasonal indicators. So based on several years of permit data beginning quarter 4, 2000, which is going to correspond as time period 1, an analyst reported the trend line that describes the permit to be my equation is equal to an intercept plus an overall trend times time. Assuming that a multiplicative model can be used to describe the building permit data, generate a forecast for that number that you expect to happen in quarter 3 of 2005. Well, there's a couple of things going on here. One of the pieces of information that we want to take into account for the data is that the data starts in 2000, quarter 4. So we have year 2000, and in year 2000, we have quarter 4, and that's time period 1. Now, after that, we're going to have 2001, 2002. We're going to need to go down further and further. Ideally, this will let me. So if this is quarter 4, then in 2001, we're going to have quarter 1, quarter 2, quarter 3, quarter 4. So as far as time periods is concerned, this is just 2, 3, 4, 5. Then we'd have quarters 1 through 4 again in 2002, right? So we'd have quarter 1, quarter 2, quarter 3, quarter 4. And so since there's 4 quarters, we'll end up with 9. In 2003, we're going to have quarters 1, 2, 3, 4. So 4 more will give us 13. In the next year, which is 2004, we're going to have 4 more. So quarters 1, 2, 3, 4 will get us to 17. And then finally, we're at 2005. And so in 2005, we're going to have quarter 1, quarter 2. But the data that we're going to be trying to predict is going to be quarter 3. And so this ended at 17. So then we're going to have 18, 19, and 20. And so the specific time period, the amount of time we've gone through in trend to get from quarter 4 in 2000 to quarter 3 in 2005 is that we've gone through 20 iterations of time periods. So the t in our time for our equation is going to be 20. Our equation, the prediction we're trying to make, is 566 plus 11 times t. So we need to actually work out exactly how many time periods have transpired in order to get the 20 that we're going to put in here. So to get the first part of our prediction, to put it into our model, we need 11 times 20, which is 220. So we're going to take 566 plus 220. And if we add 220 to 566, we're going to get 786. And that would be our prediction if there was only trend. But we have to remember there's a quarterly model. And so after we get our conclusion, after we figure out how many time periods have gone through and plugged it into t, at the very end we have to multiply by the index that goes with that time period. So since we're in quarter 3, our very last step is to multiply this by 1.3. So if we take 786 times 1.3, we're going to get 1,021.8. Okay, so the first piece of information you're going to have to figure is how many time periods have transpired. If you have to write it out until you get comfortable finding it. Once you get what that t is going to be, you're going to plug it in, and then that's going to give you an answer. The very last step is you figure out which period of time you're in, and you multiply by that because that's the multiplicative part of the index.